fascinating deep dive.
We're talking everything from quantum leaps in computing to a material as strong as steel but light as foam, so strap in. First up, Microsoft's diving into the world of quantum computing.
They've unveiled this thing called the Majorana 1 chip.
And it could revolutionize fields like, medicine and AI.
Right. Like imagine a computer that's millions of times faster than the ones we use today.
What?
That's the promise of quantum computing. And this Majorana 1 chip, it's a big step. It uses Majorana fermions. It's wild.
So like sci-fi stuff coming to life.
Yeah, exactly. And if Microsoft's right, practical quantum computers could be here in like a decade.
Wow, so think about it. Drugs designed super fast, AI solving crazy problems, and cybersecurity that's basically unbreakable.
Yes, exactly.
But what about the cost of all this? And
Yeah.
isn't building these systems super complicated?
Oh, definitely. Building and maintaining these computers is a huge, huge undertaking. But the potential is so big that companies and governments all over are pouring money into it.
It's like a global race to quantum supremacy or something.
Kind of, yeah. So while there are still some hurdles, the future of quantum computing looks really promising.
Okay, enough physics for now.
Yeah.
How about something a little more down to earth?
Okay, sure.
Imagine charging your electric car in the time it takes to grab a coffee.
Oh, yeah, like 10 minutes.
That's right.
There's a new lab in Spain. They're working on making that a reality. They're developing batteries that can charge that fast.
No more range anxiety, I'm in. But how does this super fast charging affect the battery's lifespan? Isn't that a problem?
That's a good question. Researchers are still working on that, trying to balance faster charging with keeping a battery durable.
You got it.
And, of course, there's the cost, which could be high at first.
Yeah, always the cost.
But for sustainable transportation, it's huge.
Okay, so we talked about electric vehicles, but get this. Ammonia-powered engines. Researchers are looking at ammonia as a fuel source.
Yeah, it sounds weird, but ammonia has these interesting properties that make it a possible alternative, especially for things like heavy vehicles and generators.
Okay, so I have to ask, isn't ammonia bad for the environment?
Well, it doesn't produce carbon dioxide when it burns, so that's good.
So it's like a low-carbon option?
Right. But it can produce nitrogen oxides, and those are pollutants. So researchers are working on minimizing those.
So like always, it's a trade-off.
Yeah.
But the possibility of cleaner fuel, especially for industries that are hard to electrify, that's worth exploring.
Absolutely.
Now, back to batteries. The quest for better batteries never ends. And there's a Spanish company, Flowtech, doing some interesting things with silicon anodes. What can you tell us about that?
Oh, yeah, silicon anodes, those could be a big deal.
How so?
Well, they can store way more charge than the typical graphite anodes in most batteries, like up to 10 times more.
Wow, that's a lot. So my phone could stay charged for days.
Potentially, yeah.
But come on, there's got to be a downside, right?
Yeah, silicon expands and contracts a lot during charging and discharging.
So like it swells up?
Kinda, and that can cause the battery to wear out faster.
Ah, I see.
But researchers are working on ways to fix that, like using nanostructured silicon or making new electrolytes that can handle the changes.
So it's about finding that balance.
Exactly.
Okay, get ready for this. A material as strong as steel, but as light as foam. It sounds impossible.
It's pretty amazing. Scientists at the University of Toronto developed it.
How do they even do that?
It's all about the nanoarchitecture, how the material is structured at a super tiny scale.
Nanoarchitecture.
Okay.
And the structure, it gives it these amazing properties.
So like lighter cars that use less fuel.
Exactly. And aircraft that can carry more while using less fuel too.
Wow.
But there are challenges like the cost and being able to produce enough of it.
Yeah, I was going to say, it sounds expensive. It is right now.
Yeah.
Researchers are trying to make it cheaper to produce, on a large scale.
Makes sense.
But the potential is huge.
Okay, now for a problem that's, kind of close to home for everyone, plastic pollution.
Yeah, it's a big one.
But researchers in Japan are working on a solution. A plastic that biodegrades in seawater.
This could be huge, especially for dealing with those microplastics that are polluting the oceans.
Right, because regular plastic takes, like hundreds of years to decompose?
Yeah, it's crazy.
But this new stuff, it breaks down in seawater in months. Imagine that.
It's a pretty powerful idea.
But I'm guessing the cost is a big obstacle.
You're right. Making it affordable is key.
Yeah, that makes sense.
So researchers are trying to make the production process cheaper, to make it a real alternative to regular plastics.
Well, we've covered a lot already. This is just scratching the surface. Buckle up, there's more to come.
Oh.
We're back with the deep dive. Still diving deep into all those amazing advancements.
Still so much to talk about.
Okay, before we went away, we were talking about turning trash into treasure, turning textile waste into hydrogen fuel.
It's like the ultimate recycling, right?
Yeah.
And researchers are actually making it happen. They're using this thing called thermochemical conversion.
Thermochemical conversion.
Basically, they use heat and chemical reactions to get hydrogen out of those discarded textiles. And that hydrogen, it can be used as fuel.
So we could power things with old clothes.
Exactly.
Yeah.
And not just cars, think bigger, like industrial stuff too.
Like what?
Fertilizers, chemicals, all sorts of things.
Wow. But what's holding this back from, going mainstream?
Well, the process, it still needs to be more efficient. Like getting the hydrogen out takes energy, and they're working on making that part use less energy.
To make it more cost-effective, right?
Right, exactly.
Okay, but the potential is huge, especially as we're trying to move away from fossil fuels.
No doubt.
Now, remember that material we talked about, the one from the University of Toronto? As strong as steel, but light as foam.
Oh, yeah. That stuff is wild.
It sounds like something out of a comic book.
I know, right? It's all thanks to that nanoarchitecture we talked about, the way it's structured at a tiny, tiny level.
It's hard to even imagine something that small having such a big impact.
I know. But that's nanotechnology for you.
Okay, so we could have lighter cars, planes, you said maybe even protective gear.
Yeah, think lighter and safer helmets for athletes or for firefighters.
Wow, that's amazing. But what about the cost and making enough of it?
Those are the big challenges right now. Researchers are experimenting with different ways to make it, different materials to try and bring the cost down and, be able to produce a lot of it.
So it's still early days, but the future looks bright.
Oh, yeah, definitely.
Okay, let's go back to plastic pollution. We talked about that biodegradable plastic the Japanese scientists developed. Can you remind us what's so special about it?
It's all about how it breaks down. Regular plastic hangs around for, forever.
Yeah, it's a huge problem.
This new plastic, it's designed to completely break down in seawater and fast.
Like, how fast are we talking?
In a matter of months.
Wow, that's a game changer. But how does it actually work?
It uses special enzymes, ones that are already in the ocean. These enzymes break the plastic down into harmless stuff, basically.
So it's using nature to solve our mess.
Yeah, pretty much.
Clever. But is it as cheap as regular plastic?
Not yet. It costs more to make right now, which is, holding it back from being used everywhere.
Of course, cost is always a factor.
But as they make more of it, the price should come down. That's how it usually goes.
So fingers crossed for that.
Absolutely.
Now, let's go back to those ammonia-powered engines for a second. I know it sounds weird, right?
It does, yeah.
Because we usually think of ammonia as, well, not a good thing.
Yeah, and the way it's made now, it's not very clean. It produces a lot of carbon emissions.
So what's the solution?
What if we could make it differently? Researchers are working on ways to make ammonia using renewable energy, like solar and wind power.
And that would make it
Green ammonia. It could be totally carbon neutral.
wow. So instead of polluting, it could actually be good for the environment.
Exactly. And think about the industries that are hard to switch to electric, like big cargo ships. They could run on green ammonia.
That would be huge.
It would. And it shows how we can take something old, like ammonia, and reinvent it for a cleaner future.
That's pretty inspiring. Now let's get back to batteries. Specifically, those supercapacity silicon anodes. The ones that could give our devices days of battery life.
Ah, yeah, those are exciting.
They sound almost too good to be true.
Well, there is that one problem. Silicon, it expands and contracts a lot during charging.
So that's why they don't last very long.
Yeah, it causes them to wear out too quickly.
So what are researchers doing about it?
They're trying different things, like they're using nanostructured silicon or coming up with new electrolytes that can handle all that expanding and contracting.
Sounds like a tough challenge.
It is, but it's worth it, right?
Yeah.
Imagine no more battery anxiety.
That would be amazing.
Yeah.
Okay, one last thing. Quantum computing. We touched on it earlier, and it's mind-blowing.
It really is.
But it's also still very early days, right?
Yeah.
What are some of the biggest challenges researchers are facing?
Well, it's a really delicate technology. Like the quantum bits or qubits, they're super sensitive to anything around them.
Even like vibrations or something?
Yeah, even tiny things can mess up the calculations. So researchers are trying to make those qubits more stable.
It sounds incredibly complex.
It is. But think about the potential. It's worth the effort.
Absolutely. It's a glimpse into a whole new world of possibilities.
And we're back for the final part of the deep dive. We've covered some incredible ground today, from quantum particles to plastic-eating enzymes. It's mind-boggling.
It really makes you think about the future, doesn't it? And how fast things are changing.
Absolutely. But something we touched on earlier that really stuck with me is the idea of technology being a tool. Like, we have to use it wisely, right? Not
Yeah.
just because we can. Yeah, that's so important, especially now as these advancements become, more and more a part of our lives.
Like, take quantum computing. It has the potential to, like, revolutionize everything, but there's also this whole other side to it, like data security, right?
Exactly. Think
Yeah.
about it. Quantum computers could crack all the encryption we use, for banking, for national security. It's a whole new level of risk.
It's almost like opening Pandora's box, right?
Hmm.
We get all this incredible power, but we have to be really careful with it.
I agree. It's a trade-off, for sure. And it's not just quantum computing. Like, those new materials, the strong but lightweight ones, they could be amazing for so many things. But what about the environmental impact, right?
Mhm.
Producing those materials could be a problem.
So it's not enough to just invent something new. We have to think about the consequences, the bigger picture.
I think so, yeah. We need to be responsible with these technologies, guide them in a direction that benefits everyone, not just a few.
Well said. It's a good reminder that progress isn't just about, the technology itself, but about using it to make the world better.
Couldn't agree more.
So before we wrap up, I want to leave you with something to think about. All this incredible stuff we talked about today, it makes you wonder, what else is out there? What other amazing discoveries are just waiting to be made?
Right. What seems impossible today could be commonplace tomorrow. It's a pretty exciting time to be alive, if you think about it.
It really is. Well, it's been a fantastic journey exploring these advancements with you. Thanks for being here.
My pleasure. It's always a great conversation.
And to everyone listening, thanks for joining us on the deep dive. Remember, the future is full of potential, and it's up to all of us to, make sure it's a good one.
Stay curious